Hi, I'm Thomas Mucha, and in this video, I'm going to show you how generative AI technologies can power new features in existing business software applications. We are going to be adding a new feature to an existing workflow for purchase order approvals. This video includes also a bonus hint on how to rapidly prototype and build mockups for such new features without the need for coding. In this example, we will look at how large language models can be used to extend capabilities of existing software. We will be looking at an imaginary case of a purchase order approval tool. In this case, I don't actually have a purchase order approval tool, but instead I am working with an Excel document. So it represents for me a purchase order approval tool. And the way it works is that decision makers, when they need to decide whether they approve this type of purchase order or not, they don't have access to all relevant information, especially not timely access, because the state of the world is changing all the time. So in this fictionary case, we are going to be adding a new feature that allows decision makers to access information in more real time by leveraging large language models, right? So what I'm going to do next is first I'll show you, okay, now we have added this new feature. So this is going to be a button that allows the decision maker to scan news to identify emerging risks. And in fact, this is just an image of a button that I added to Excel. So that's the bonus hint here. If you want to prototype new features in software, you can actually do it by adding a picture of a button and follow the steps that I'll be showing in a moment. So what I'm going to do next is I can save this document as a PDF file, which I actually already have ready. So this is the PDF file that we have created from Excel, and it has these two buttons. So let's first have a quick look at this purchase order, and then we will proceed with the example of how we can prototype new features that are leveraging large language models without any coding and in a matter of few minutes. So right now we have some dummy information here, some purchase order number, dates. All right, we have supplier information, and then we have our company information, and then some product we are ordering, in this case fish oil. Right, so the way we are going to prototype is we will be using Copilot, which is integrated with Edge browser. So I opened this PDF file inside an Edge browser, and now I have this Copilot in the Edge available for use, and Copilot has access to documents that are open in the browser. So the way the prototyping works is that we need to, of course, imagine a little bit that when we click on this button, certain actions will follow. But in fact, we will be typing prompts here in the chat box, which would be representing the logic of the program that we are trying, or of the feature that we are trying to prototype. So let's say that when approving a purchase order, the decision maker maybe would like to check the latest status of the supplier. Is there any emerging risk, something that's happened recently in in either their company or in the region. And in real world, in practice, these decision makers, they don't have enough time to keep on checking all the time the status of their suppliers. So there's always some information that is lost because of that, and that creates risks for organizations. So if we add this kind of feature, scan news to identify emerging risks, we might be reducing exposure to risk for some companies. So let's imagine that I press this button, and now there will be the first task that a large language model based tool will generate. So first, it in a way needs to load in some information from this purchase order. So let's say find the details of a couple of items from this purchase order. And now I think this is also an interesting point that I wanted to show you in this demonstration. So you need to realize that this kind of purchase order document, it represents a type of potentially confidential information that you would not want to share outside of organization, your own organization, without, let's say, at least openly on the internet, without being able to control who accesses this information. So now this pop-up here, let's not save this conversation, is actually an indication that Microsoft, because the Edge browser is provided by Microsoft, is aware that some people upload information to ChatGPT and other large language-based models, information that should not be going out into the wild. So they are saying that they will not be saving content of this chat history, which in a way is also a good wake-up call in case some people would be sharing information that they shouldn't with this types of models, because of course the information needs to leave their computer and go somewhere for processing. But in this case, this is fictionary data, so there's no problem. So in terms of prototyping, of course, be aware of what type of data you're using when prototyping. But let's go ahead. Let's check the answers here. So PO number, everything looks good. So now the next step that this feature should trigger is as follows. We would like that Copilot in this case, or it could be, of course, if it was a real application, our application, in the background searches for the latest news about the supplier, but also news related to the area where the supplier is located. And then, in case there are some emerging risks appearing in these results, then provide a brief summary of them. So let's see what Copilot will find in this case. So you can see that Copilot is able to access information from the internet. It's providing links to references where the information comes from, which is very handy. And another important thing is that it's able to access information that is up to date, right? Because it's querying through Bing browser the status of, well, basically browsing the internet. So it can access the latest information, which is useful in this case because, as we can see, now Copilot identified, as expected, or as I was hoping, because as you might have probably already noticed, the supplier is actual a real company, but it's based in Iceland, in a location near to the volcanic eruption that took place recently. So let's see. So it has identified these risks here. All right. And let's see the recommendation. All right. So it looks like very reasonable conclusion that there are significant risks related to this purchase order. But okay, this is not the end of the workflow that we would want to have in the tool. It is great to have information available, but let's make it more actionable. So our tool could have another, let's say, logic integrated there, that in case some risks are identified through this search, we can follow up with the supplier. So continuing with the logic of sending the prompts as a representation of what would be happening inside this program, we are asking the model to generate a draft of an email that we could send to the supplier to inquire about their ability to really deliver on this purchase order. And here you can see that Copilot is generating a draft for us, and it is providing some details that were included already earlier in or that were identified earlier directly from the purchase order. It is using information. It is using information from its search results. And then it is providing also some dummy input here. So our phone number. So this is something that we would definitely need to revise. But in terms of the end-to-end process from, let's say, thinking about, is there any emerging risk related to the supplier, to the action that we can take to send an email, if we compare the workflow that would need to be, let's say, processed if we do everything manually, this would take probably at least half an hour, if not more. In this case, it took just maybe two minutes, maybe 1 minute, and of course I was explaining things here, and we were running these prompts in a slower pace than it would be integrated in software. So you can see the potential value in integrating this type of tool to really enable some activities that were not feasible just because of lack of time, not because of lack of skills. So of course, the decision maker that makes the approval here would be able to do all these tasks, or would be able to delegate this responsibility even to a junior staff to monitor the status of the suppliers. But there's just simply not enough time to do all these small tasks, and they can be actually executed with the help of large language models. Generative AI technologies can power a variety of features in software. These features don't need to be at the very core of applications to create meaningful business value. I hope that the example I provided in this video demonstrates that a task that user could potentially perform manually can be converted with the help of generative AI into a new feature that not only creates direct productivity benefit, but also helps to integrate this existing workflow with other parallel business processes and workflows.